everyone! In this video, I am going to show you an example of a maximization assignment problem using Hungarian solution method. So every goal of a maximization problem, whether it is transportation or assignment, is to be able to maximize a certain result. For example, if we want to assign a certain job to a certain person, we want to make sure that the result of the assignment is to maximize the efficiency. Or maybe we want to assign a certain person to a certain territory or a salesperson to a certain place to be able to maximize the profit of our company. So to be able to solve those problems, is it similar to how we solve minimization, or is it different? So to be able to solve a maximization assignment problem, we have to convert first the maximization problem to a minimization by subtracting every number in the original table from the largest single number in the table. So actually, this is also similar to what you have learned in the transportation problem, where we had to convert the maximization problem to minimization. So in this assignment problem, after we have converted it, we can proceed to the usual method, which is the Hungarian method. So let me give you an example of a maximization assignment problem, and we will solve it using these steps right here. So the British Navy wishes to assign 4 ships to patrol 4 sectors of the North Sea. The commander or the chief captain rates each ship in terms of its efficiency in each sector. On the basis of the ratings shown in the table right here, the commander wants to determine the patrol assignments producing the greatest overall efficiencies. In other words, we want to know which ship should be assigned to which sector so that at the end of the assignment we are able to produce the greatest overall efficiency. So in this table we have here ship 1. If ship 1 is assigned to sector A, then the efficiency will be at 20. If it is assigned to sector B, the efficiency will be at 60. If it is assigned to sector C, the efficiency will be at 50. And if it is assigned to sector D, then the efficiency will be at 55. So you can check other efficiencies in this table right here. Now, it was mentioned earlier that before we can proceed to the Hungarian solution method, we have to convert the table right here to a minimization table. So to convert again the maximization to minimization, we have to subtract every number in the original table from the largest number in the table. So it is very easy to spot where or which is the largest number, and it is 100. So what we will do here is that we will be deducting all the units in the table from 100. So that means we are going to do 100 minus 20, 100 minus 60, 100 minus 80, 100 minus 65, and so on and so forth. Look at this table right here. And then after we have subtracted all the units in the table from 100, the result will be this one. So this is now the new table that we will be using for the Hungarian solution method, because this is now the minimize table. So now we are going to solve the assignment problem using the Hungarian method. And remember, the first step is the row reduction. So in row reduction, we are going to subtract each row from the lowest number in that row. Let's check again the table that we had earlier. So for row 1, the least number right here is 40. So that means we will have to subtract 40 from all the numbers in that row. So 80 minus 40, 40 minus 40, 50 minus 40, and 45 minus 40. On the second row, the least number is 20. So we will have to subtract 20 from the rest of the numbers in that row. So 40 minus 20, 70 minus 20, 20 minus 20, 25 minus 20. For the third row, the least number is 0, so all the numbers in that row will remain the same. For fourth row, the least number is 20, so we will have to do 35 minus 20, 20 minus 20, 25 minus 20, and 30 minus 20, just like this table. So the result will be this one. So this is now our new table for this particular problem. After the row reduction, we're going to be doing the column reduction, wherein we are going to focus on per column. The least number in column A is 15. So we will have to subtract 15 from the rest of the numbers right here. So 40 minus 15, 20 minus 15, and so on and so forth, just like the rest of the column right here. For column B and column C, the least number is 0, so all the numbers will remain the same. For column D, the least number is 5, so we'll have to deduct 5 from all the numbers right here. So 5 minus 5, 20 minus 5, and 10 minus 5. After which, the result will be this one. So, after we're done with the column reduction, it is now time for us to do the optimality test using the line test. So remember, in line test, we have to cover all the zeros in the column and in the row by drawing vertical or horizontal lines. All right, so now that we have drawn the vertical lines and the horizontal lines needed to cover all the zeros, we will now count how many columns or how many lines are there. So we have 1, 2, 3, and 4. So we have 4 lines. And we also have 4 columns and 4 rows. So that means the number of lines is equal to the number of columns and rows. So that means this particular table was able to pass the optimality test. Now that we were able to determine that, it is now time to do the final allocation or final assignment of each ship. If you still remember, to be able to assign the ship to each sector, we have to determine, or we have to select a row or a column that has only one zero. For example, we can start with column A because column A has only one zero. So that means we will have to eliminate the rest of the columns and rows in that particular cell. So this means that ship number 4 will be assigned to sector A. Next, we now have this vacant available squares or cells. So row 3 does have only one zero in row 3. So that means we can assign that to sector B, and the rest of the rows and columns in that cell will be eliminated. Next, in column C, we only have one zero right here, so we can assign that. We can allocate that, and we will be eliminating the rows and columns in that particular cell. And lastly, we can assign ship 1 to sector D. So now, here is the table for the allocation. Ship 1 is assigned to sector D, and the efficiency is at 55. Sector number or ship number 2 will be assigned to sector C with the efficiency of 80, and ship number 3 will be assigned to sector B and efficiency will be 100, and ship number 4 will be assigned to sector A with an efficiency of 65. And the maximum efficiency or the greatest overall efficiency of this particular assignment is 300, and that is the final assignment for each ship to its sector.